Okay, welcome to the back half of this worksheet. We're going to take a look at these volume problems. One of the things that we want to be always paying attention to is what does the problem ask. The first time we were talking about volume, or excuse me, surface area. Now we're talking about volume. End of course exam, those sorts of things, the pictures are going to look the same. You need to be paying attention to what kind of information. So we have a cylinder for this first one, number 9. So area of the base, which is pi times 12 squared times the height, which is 16. We multiply all of that out, and we get 7,238.23 units cubed. For number 10, we have just a regular old prism. Same idea, area of the base, 6 times 4, times that height, which is 15. And we multiply that together, and we get 360 units cubed. For number 11, we have a pyramid. It's a regular old square-based pyramid. One of the nice parts about this is we have the height. This is the true height. So our formula is 1/3 the area of the base, which is 12 squared, times the height, which is 9. We multiply that all together, and we get 432 units cubed. For question number 12 here, I have, in fact, the slant height. I need the true height. I need this height right here. So the first thing that I need to do is to solve for that. I see that I have Pythagorean theorem. Good old Pythagorean theorem. We solve, and we find h to be 13.266. At this point, I have everything I need to find the volume. So 1/3. Differentiate them. The area of the base, which is pi times 7 squared times the height, which was 13.266. We multiply that all together, and we get 680.74 units cubed. To do questions 13 and 14, I want to have a little bit of space here. So what we need to do is to be paying attention again to what kind of information we have. And what we see here for question number 13 is that I've got a hexagonal prism. It's got a pyramid out of it. It's been sucked out of it. And I know that the height of that pyramid is in fact the height of the prism. So what I want to do first is to find the volume of the prism, and then I'm going to find the volume of the pyramid, and at the end of this I'm going to subtract them. Now, before I get too far, I need to find the area of the base. And whereas with a rectangle or a circle or something like that, I can just kind of plug through. Here I actually need to do some work with my object. It needs to do some work with what kind of information I have. This is a hexagonal top. If I draw the triangle, of which I know there are 6 of, right, so 6 times 1/2. The base of this triangle, which is the side length, is 12, and the apothem here is 10. So times 12 times 10. So that gives me an area of the base of 360. So now, volume of the prism can be my area of the base times the height, which is 15. And I find that that volume of the base is, or the pyramid, excuse me, is 5,400 units cubed. Volume of the pyramid, 1/3 the area of the base, which is 6 times 5, times the height again. I know that it went all the way through, so that's 15. I plug through, and I get 150. So my volume total, we said, was going to be the volume of the prism minus the volume of the pyramid. 5,400 minus 150. I subtract those, and I get 5,250. For question number 14, I have hexagonal prism that is topped off with a hexagonal pyramid. Now they share the same cross-section of the base. So if I find the area of the base of the prism, I'm going to find the area of the base of the pyramid. Again, I'm going to start with that triangle that I know there are 6 of. I look here and I see that the side length of that hexagon is 50. The height of the prism is 15. So all I know about this triangle here is that the side length is 50. Luckily, I do remember that the central angle is going to be 60 degrees and that this angle here is going to be 30 degrees. That means this is 25. So I use my special right triangle. 30 is at the top, so that's 2, 1, radical 3. That means that my height, h, is equal to 25 radical 3. h over radical 3 is equal to 25 over 1. I can find the area of the base now. That is going to be 6 triangles times 1/2 side length, which is 50, or the base of that triangle, times the height of the triangle, which is 25 radical 3. Multiply all that out. And then, and then I need to take that times the height. Sorry, messed up here. So I'm going to multiply all that out. I do need to take it times the full height. Let's find out what that is first. And that is 6,495.19. The volume of the prism now is going to be that area of the base times the height of 15, and that number is 97,427.86. The area of the base is going to be the same for my pyramid. So that should be pretty easy. 1/3 the area of the base times the height, and I know that that height is 8. So that makes this value 17,320.508. And in order to get to my final answer, I'm going to take this value here and this value here, and I'm going to add those together, because that'll be my volume total. And I add those together, and I get 114,748 units cubed. Now, this is a wonderful illustration of why we want to carry out those decimal places. When we start multiplying by these big numbers, we end up seeing that a small decimal makes a big difference. Okay, that is question 14. Compound objects. You need to know how to deal with compound objects. And then let's look at our sphere questions. Our sphere questions. So, first, I've got a sphere with a radius of 25. So, volume of that, excuse me, is equal to 4/3 pi times the radius, which is 25, cubed. I multiply all that out, and I get 65,449.85 units cubed. For question 16, you want to find the radius of a sphere when the surface area is 956 units squared. So this is not a volume problem, but I should be able to handle it pretty easily, because all I'm doing is some algebra. I solve for r squared, which is 76.07. Take the square root of that, and I find that r is equal to 8.72. So, these are all of the answers to the things that you need to know for your test tomorrow. I will tell you, since you've listened thus far, there will be a problem where you're going to take this kind of information. You're going to be given a surface area, you're going to solve for the radius. You're then going to take that radius and find the volume of that same sphere. So, big hint for you. Take the radius from the surface area equation, use that to solve for the volume. As well, don't forget, you need to know what the definition of a polyhedron is, as well as you need to be able to explain what Cavalieri's principle is. You need to be able to explain how we use Cavalieri's principle. That's it, and good study.